Well, in this section, we're going to talk about logarithm functions. And you'll notice at the beginning, the variable setup, the x and the b, both being positive numbers and b not being equal to 1. Well, that's similar to the previous section when we talked about exponential functions. So, for positive numbers x and b, where b is not equal to 1, this equation, which is what says y equals log base b of x, is equivalent to the equation b raised to the y exponent is equal to x. These are equivalent. If you want to solve one that looks like this, you can convert it into an exponential, and they are equivalent, so the solutions would be the same. All right, and just I'll probably do this again later, but when I see an expression or equation like this, I usually draw arrows. I start from the b, and then I go b raised to that number gives me that number. It's just something I like to do. B to the y equals x. So this function, as we just said, it's the logarithm function with base b. And the way we would read this is f of x is equal to log base b of x. And the only reason I'm putting this next thing in is because this is the way I learned it many years ago, and you can forget this if you like. But writing this like an English sentence, I would say y, which corresponds to that y, is, which corresponds to the equal sign, and then log means exponent. Y is the exponent. That's the word log. You raise the number b to get x, or to obtain x. So it's just a way of looking at this as an English sentence, reading it left to right. Y is the exponent that you raise b to get x. And I don't want to jump too far ahead, but you could deduce from this statement y is an exponent, which means log base b of x. That's an exponent. And what exponent is it? It's the exponent that you raise b to get x. This is an equation. I should have put the b a little bit closer there. B raised to this exponent gives you x. And we'll talk more about this later. So I'm jumping ahead a little bit here. So don't worry about all this right now. All right, let's start at the very beginning. In a log expression, if we omit the base, remember we said base b here? If that's left blank, it means base 10. So all that means is that if you ever see something that says log of w, the base of that is log base 10. It's kind of implied if you leave it out. All right? Well, let's use what we just talked about a minute ago. We're not going to do any solving here. All we're going to do is take a log equation and translate it into its equivalent exponential equation. So we're going to use exponents instead of the word log. And again, one quick way I like to think of it is you start at the base of the log. I draw that arrow, and then I draw that arrow. It means 7 raised to the third is equal to x. I mean, I would probably write that x equals 7 to the third. Either way is fine. So it didn't say solve it, even though we did solve this. We didn't simplify. We don't have to multiply 7 times 7 times 7, raising 7 to the third power, because all we wanted to do was translate it. Okay, so let's do it again with this one. Looks like we're going to get a b to the second power equals 25. And by the way, what would the solution to this be? Normally, under normal circumstances, if you're only given this, you would say, using the square root property, you would say b is equal to plus or minus radical 25, or plus or minus 5. But a base of a log can never be a negative number. It's always positive. So the solution would be b equals 5. But again, we weren't asked to solve. We just wanted to write this log equation into an equivalent exponential equation. All right, the last one of these would simply be 4 raised to the y equals 26. Again, my arrows I like to draw like that. All right, for our last example in this video, let's go the other direction. Let's start with some exponential equations and translate them into logs. This one I always have to double check my work. But I know I need a log, the word log. And remember that the base of the exponent term, the base is 2. So that's also going to be the base of the log, 2. And the exponent is 5, so the x goes there. I always like to test it by going backwards using my arrows, my arrow technique. 2 raised to the 5 gives me x. And that's exactly what we have there. Okay, so this one is going to be a log base b, since b is the base of the exponent term. So log base b of 27 is 3. And I'll double check it. b raised to the 3rd gives me 27. That's exactly right. All right, last one. The log base x of 33 is equal to y. If I were checking it going backwards, x to the y gives me 33, which is exactly what we have here.